Hello everyone and welcome back to IM Technos. In today's video, we're exploring one of the capabilities in AWS Systems Manager called Incident Manager. Imagine your production application goes down at midnight, customers are calling, your CloudWatch alarms are red, and you're scrambling to find the right person to fix it. What if AWS could automatically detect, notify, and even run recovery steps for you? That's exactly what Incident Manager does. Think of it like an emergency response system. In the last video, we discussed OpsItems in Ops Center, which act as a ticketing system for non-urgent, low-critical operational issues that are usually resource-specific problems. By contrast, an incident represents a major outage or critical issue. These are high severity and urgent situations that affect application availability, reliability, or customers. AWS Incident Manager is designed to help teams respond to such critical applications or infrastructure issues quickly and effectively. The process begins with setting up contacts, which define the individuals or teams to be notified during an incident. Next, we create an escalation plan, which ensures that if the primary contact does not acknowledge the alert, it automatically escalates to the secondary contact, such as managers or stakeholders. With the escalation plan in place, we then define a response plan. A response plan brings everything together. It links to escalation plans for notifications and also specifies automated actions such as running SSM automation runbooks, invoking Lambda functions, or engaging chat channels like AWS chatbot. When an incident occurs, Incident Manager automatically triggers the response plan, notifies the right people as per the escalation plan, execution manual or automated recovery actions to reduce the downtime. Finally, once the incident is resolved, you can use post-incident analysis to help the team review what happened, identify the root cause, and improve future response processes. Now let's see how we can implement this in a real-time scenario. First, we will launch an Amazon Linux EC2 instance and attach an IAM role that gives it SSM permissions so that it can be managed through System Manager. Next, enable Incident Manager for the region we are working in. After that, create contacts and add an email address that should receive notifications during an incident. With contacts in place, create an escalation plan that defines who to notify and when to escalate if there is no acknowledgement. Then create a response plan and link the escalation plan to it. In the response plan, add the instance identifier and configure the automation runbook to restart the instance. Now create a CloudWatch alarm on the EC2 CPU utilization metric and configure the alarm to create an incident using the response plan when the CPU crosses the threshold you set. To test the setup, we put some load on the EC2 instance so the CPU goes high. When the threshold is crossed, the CloudWatch alarm goes into in-alarm state. This immediately creates an incident, triggers the response plan. The response plan then notifies the contacts you specify and automatically runs the restart runbook to bring the instance back to normal. The runbook is optional. You can choose it to run manually or perform manual remediation steps. As soon as the CPU drops and stabilizes, this brings instance back to healthy state and the CloudWatch alarm returns to OK state. At that point, we mark the incident as resolved. And if needed, create a post-incident analysis to review what happened and improve the process. Let's start by creating an IAM role for the EC2 instance. I'm in the AWS Management Console. In the search bar, type IAM and open it. On the left side, under Access Management, go to Roles and click Create Role. For the trusted entity type, keep it as AWS Service and under Use Case, choose EC2, then click Next. On the permissions page, search for Amazon SSM Managed Instance Core, select it, and then click Next. Give this role a name. Let's call it as SSM role. Scroll down and click Create Role. That's it. The IAM role for EC2 with SSM permissions is ready. In a new tab, open the EC2 service and select Launch Instance. Give the instance a name. For example, Recovery Test Instance. For the AMI, keep Amazon Linux And for the instance type, choose T2 micro. Under the key pair, select proceed without a key pair. Leave the defaults for both network settings and configure storage. Now expand advanced details. And under instance profile, select the role created earlier, which is SSM role, then click launch instance. Scroll down and click view all instances. The instance now is up and running. Now let's set up Incident Manager. In a new tab, open Systems Manager, and from the left navigation, under Operation Tools, choose Incident Manager. Since this is first time setting it up in this region, click Get Prepared, then click Setup. Accept the terms and conditions by checking the box and click Next. You will see the region we are working is already selected. Just scroll down and click Create. As mentioned here, it usually takes about 5 minutes for the Incident Manager to be fully set up. The setup is now complete. Next, let's move on to creating our contact details. Now click Create a Contact. For the name, enter Critical Incident Contact. For the unique alias, use App Support Contact and make sure to keep it in all lowercase. Under Contact Channel, choose email as a type. Give a channel name. Here I'll use IamTechnos. In real projects, you would normally put the client or the team name. Enter the email address where you want to receive notifications and then link it to this contact. Next, under engagement plan, select the channel name. You will also see the engagement time, which is basically the delay before notifications are sent once an incident starts. For this demo, I'll keep it as 0, so notifications go out immediately. Now scroll down and click Create. At this point, AWS sends an activation code to the email we entered. This is to verify ownership of the contact. Copy the code, paste it back here, and click Finish. Remember, the user has to complete this activation step. Until the code is confirmed, the contact remains inactive and Incident Manager won't use it in any escalation or response plan. Now let's move on to creating an escalation plan. In the Incident Manager console, click Create Escalation Plan. First, under Escalation Plan Details, enter a name. For this demo, I'll call it as High CPU Escalation Plan. For the unique alias, type High CPU Escalation. Remember, the alias has to be in lowercase and must be unique within this region. Next comes the stage 1. This is where we decide who gets notification when an incident starts. Notice the option for stage duration. This is the delay before moving to the next stage. Since this is our first stage and we want notifications immediately, leave it as 0. Now, under escalation channels, select the contact we created earlier. Once selected, you will see the option Acknowledgement Stops Plan Progression is checked. That means as soon as someone acknowledges the incident, the plan won't continue to the next stage. This is useful in real-world scenarios to avoid spamming multiple teams. If needed, additional stages can be added. For example, stage 2 could notify a senior manager after 5 minutes if no one responds. For this demo, we will just stick to one stage. Scroll down to the bottom and click Create Escalation Plan. Our escalation plan is now ready and linked with the contact we set up earlier. This plan will be referenced in the response plan when we define how incident should be handled. Now let's create the response plan. On the left-hand navigation, under Incident Manager, click Response Plans. Here, select Create Response Plan. At the top, under Response Plan Details, type a name. I'll call it as High CPU Response Plan. You can also give a display name to make it easier to identify, but that's optional. Next is Incident Default section. Here we define the default information that will automatically be applied when an incident is created using this plan. For the title, enter something descriptive like High CPU Utilization Detected. Under Impact, choose the level of severity. For this demo, I will select Impact 3, which is medium. But in production, that should match your organization's severity matrix. In the summary, provide a short description. For example, EC2 instance running production workload is experiencing high CPU usage. Immediate attention required. Below that, there is a field called dedupe string. This is optional, but it helps incident manager avoid creating duplicate incidents with the same root cause. For example, if multiple alarms fire for the same issue, they'll get grouped under one incident if the dedupe string matches. Now let's look at the optional settings available when creating the response plan. The first section is chat channel. This is where you can integrate with AWS chatbot to notify your teams directly in their chat clients like Slack or Amazon Chime. You will need to associate an SNS topic for the notifications. For this demo, I leave it blank, but in real setup, you could select a chat channel here. Next, we have engagements. This allows us to connect escalation plans, contacts, or on-call schedules in this response plan. Essentially, it is how the right people get notified when an incident occurs. Since we have created an escalation plan and contact earlier, you could add it here by selecting the drop-down. Moving on, there is the Runbook configuration. Runbooks are the automation documents in AWS Systems Manager that can guide or even automatically resolve incidents. Instead of cloning a template, I'm going to select an existing runbook. Under owner, I'll choose owned by Amazon. From the list, I'm selecting AWS restart EC2 instance as the runbook, and I'll make sure the latest version is selected. Now in the instance ID field, I will copy and paste the ID of the EC2 instance that we launched earlier, making sure it's in the right format. Now coming to the automation assume role, please understand that in order for the restart runbook to stop and start the EC2 instance, we need to create an IAM role that the runbook will assume with the necessary permissions provided by an AWS managed policy. Now under automation assume role, I will create a new role. Next, under AWS managed policy, I will attach the policy called Amazon SSM automation role. Now this role with the policy attached is what the runbook will assume to safely perform the restart operation. We also need to create another role that allows incident manager to start the runbook workflow whenever an incident is triggered. So it works like this. The incident manager service role gives permissions to start the runbook workflow when the incident is triggered. And the automation assume role gives permissions to the runbook itself to restart the instance. So back in the console, under runbook service role, choose create a new role and the role name is automatically populated. This is the role that incident manager will use to restart the runbook workflow whenever an incident is triggered. Now that both roles are in place, I'll scroll down and click create response plan. We have set up the response plan so that whenever it is triggered, it immediately sends out the notification and restart the instance by invoking the runbook. Now, let's create a CloudWatch alarm on the CPU utilization metric of our EC2 instance. In a new tab, search for CloudWatch and select from there. In the left navigation, click on all alarms. Please ignore the alarm, it's already been created. Now click create alarm. Click select metric. Under browse tab, choose EC2 and click pre-instance metrics. Go to EC2 console, copy the instance ID and paste it in the pre-instance metric search bar. Now under the metric name, search for CPU utilization and enable it. And on the right side down, click select metric. Scroll down. Now we want the incident to be created whenever the CPU is greater than 70. So under conditions, keep it as 70 and click next. Now we are at the notification setting for the CloudWatch alarm. With the CloudWatch alarms, we can not only automate the creation of the incidents, but also receive notifications via email using Amazon Simple Notification Service or SNS. But keep it in mind that SNS is different from the contacts we created earlier in the incident manager. For now, Just think of SNS as a basic notification service. Even though it won't play a direct role in this particular demo, we still needed to set it up to complete the alarm configuration. I'll set the alarm stage as in alarm, which means a notification will be sent whenever CPU utilization goes above the threshold. Now click on create new topic. For the topic name, I'll give a name like high CPU alarm topic and add an email address as a subscriber. Once I hit create topic, an email is sent to that address for confirmation. Open your inbox, click on confirm subscription, and only then the notification will start coming through. Now, whenever this alarm is triggered, CloudWatch will push the message to the SNS topic and all confirmed subscribers will be notified instantly. Next, scroll down to the System Manager action. Here, I want the CloudWatch alarm to automatically create an incident. So I will select the create incident and then choose the response plan we created earlier and click next. I'll give alarm a name as high CPU alert. And for the description, I will add high CPU alarm for recovery test instance. Scroll down and click next. And on the review page, hit create alarm. The CloudWatch alarm is now created and you will see it's currently in insufficient data state. Soon, it should move to OK state. The CloudWatch alarm in OK state means the alarm has started receiving metrics from the instance and the CPU utilization is currently below the threshold we defined, which is 70%. Now that everything is in place, let's put it to the test by stressing the EC2 instance CPU. Once the CPU utilization goes beyond 70%, the CloudWatch alarm will switch to the in alarm state. This in turn will trigger the incident, invoke the response plan, send out a notification, and finally execute the runbook to automatically restart the instance. Head over to the EC2 console, select the instance, and click connect. Under EC2 instance connect, hit connect and wait for the session to establish. Now run the command empty stat 1. You can see the CPU is almost completely idle, showing close to 100% idle time most of the time. Press Ctrl C to stop the process. You can also check this visually from the instance console. Select the instance, go to the monitoring tab and expand the CPU utilization metric. Here too, you will notice the graph is flat, confirming there is barely any activity happening. Now let's install the stress tool. For that, run sudo yum install stress. Once installed, in order to increase the CPU usage of this instance, run stress -CPU2. Now head over to the CloudWatch console and monitor the alarm. You should see the transition from the OK state to in alarm state once the CPU crosses the threshold. Now in the CPU utilization metric, keep refreshing and you will notice the usage steadily climbing, first around 10%, then 20%, continuing upward. In another terminal, type nstat1. Here you can see the CPU is being heavily used, almost hitting 100% utilization. Back in CloudWatch metric, once the CPU crosses 70%, in the CloudWatch console, the alarm transitions to in alarm state. Now this automatically triggers the incident we configured earlier. Along with the incident, the response plan kicks in, sending a notification to the contact and starting the runbook execution to restart the instance. Now open Systems Manager and click Incident Manager. You can see a new incident has been created and it's currently in open state. And you'll also notice the runbook is in progress state. Let's wait for the execution to complete. In that meanwhile, check your mail. You should see a notification like this. Now back in the Incident Manager console, you can see the runbook execution shows as success. Now if you switch over the EC2 terminal, notice that since the instance has been restarted, the session is no longer active and you will see this message here. Now let's reconnect to the instance. Select the instance and click on connect. Now go to EC2 instance connect. Run empty-stat 1. The CPU is back to idle, confirming that the issue is resolved, and the CloudWatch alarm transitions to OK state. At this point, the instance has returned to the healthy state, so we can proceed to resolve the incident. In the incident page, click Resolve Incident and confirm it. The incident status changes to resolved. If you want, you can also run a post-incident analysis using the template to review what happened and dig deeper into the root cause. For this demo, I'll skip this step. Now the final part is cleanup. Since we created several resources, it's important to delete them to avoid unnecessary cost. In a new tab, search for SNS and select it. From the left-hand navigation, choose the topic we created, select it, and click delete. Give the prompt and confirm the deletion. After that, go to subscriptions, select relevant subscription associated with the topic and delete that as well, confirming the prompt. Now open the CloudWatch, select the alarm we configured, go to actions, choose delete and confirm the deletion. Now go to Systems Manager. From the left navigation menu, under Incident Manager, select Response Plans. Choose the response plan we created and click Delete. Type the response plan name and confirm the deletion. Still under Incident Manager, select Escalation Plans. Choose the escalation plan and click Delete and confirm the deletion. In the same way, go to Contacts. Select the contact we created and click delete and confirm the same. If you want to completely remove all the traces of the incident manager setup, go to settings, select the region you configured and click delete. Type delete and confirm the same. This setup usually takes a while to complete. While this is processing, go to EC2 console, select the instance we used for the demo, go to instance state and choose terminate instance and confirm the termination when prompted. Finally, open the IAM console, refresh the list of roles, select the role we created earlier. Along with that, select the AWS restart instance role and Runbook assume role and click delete and confirm the same. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching and I'll see you in the next video. Take care and happy learning.